What? You're back for more? You guys are crazy. You would think you've had enough of me by now, but you haven't. And today is an exciting day because we actually get to start talking about our first organ system, the integumentary system, aka the skin. So you got me. This is lecture number 1 of chapter 5, and you got my little girl with us too, right, Jenny? Baby girl. She's like, I'm here, Mom. So, she also thinks this is a lot of fun, I guess. I don't know. It's a beautiful Sunday. I'm in here recording lectures. I get to go to work later. Woohoo! So, let's get this party started. In case you're wondering, I am wearing makeup today, and it's not for you. Sorry. You only see me with a mask on anyway. I have a Zoom meeting with all my college folk, my college peeps, so that's in a couple hours, and who knows where I'll be in a couple hours, so I thought I'd better look half alive now so that I'm not the worst looking one in the bunch. I probably still am, but it's all good. All right, well, we are going to start. And because you're like, all right, Laura, enough with the small talk, giddy up. Oh, hi, Spunk. What's up, babes? I'm interrupted by this little girl. Did you want to come and say hi? She's like, no, I just want to know why you're talking. Hold on, I'm trying to get full screen so you guys can see another one of my beautiful girls. Hi, Spunky. She's like, okay, enough. You want to go to that chair? Okay. Come and keep me company, too. All the girls here with me. I guess this is a special day. Now I'm very distracted. I'm sure you feel the same way. All right, babes. She misses Jared. He's at college, and they used to spend every day together on his bed. Well, he would be watching YouTube, and she would just be laying there, and so she's missing our little buddy. But I'm sure you know how it feels. All right, so the integumentary system. Your skin. Done. No. Never. I'm trying to figure out. Okay. So the integumentary system consists of accessory organs, which you don't really think of as accessory organs, but those are like your nails and your hair, your sweat glands, your oil glands, serving very different purposes. We'll get to talking about that. And then the actual layers of skin, that is that protective barrier. One of many functions of the skin, but again, here's a couple functions. So the skin helps the body maintain its temperature. So let's think about that for a second. Now I have cat hair on my face and it's tickling me, sorry. Right, we have sweat glands to help the skin cool when it's hot. But what are some mechanisms in the skin when we're hot, it helps us cool. You sweat when you're hot. When we're cool, what does the skin do to help us stay warm? Well, we've got those little hairs on the skin, and they might pop up as goosebumps with these little muscles we're going to see in a beautiful picture of the skin. We have blood vessels in the different layers in the dermis. There's 3 layers to the skin, epidermis and the dermis, and a 3rd layer that they don't really call a layer, but I still do, the hypodermis. And blood vessels can go deeper in to conserve heat as well. So there are 2 opposite ways that the skin helps to maintain body temperature. It makes vitamin D active, sunlight. Sunlight hitting the skin will activate vitamin D. And why do we even care about vitamin D? It's just a letter, the letter D, duh, right? We need vitamin D in order to absorb any calcium across our digestive tract. Calcium can't cross on its own, so it kind of holds hands with vitamin D, and they come across together. So vitamin D is critical, which is why they add it to milk, right? Milk contains calcium, but if you don't have the vitamin D, then it doesn't really matter. And then we have a lot of different sensory receptors in the skin, and we're going to be talking about that in the lab in a couple of weeks. And we get a lot of information through our skin. We get temperature. Is it warm? Is it cool? We get pain. We get pressure. We get tactile, a little light touch. And then there's even like every little hair, when I'm like the hairiest person I know, every little hair has a nerve receptor associated with that follicle to know if something's walking on your hair, not even on your skin. My cat left. Like I said, I'm distracted. All right, so, okay, what does it contribute to? Let's talk about the structure. And the structure is this beautiful picture. My nose is stuffy because I think I'm a little allergic to that little girl, but whatever. I will still snuggle her up. So what we have in the skin are 3 layers, the epidermis. And we're going to talk about the epidermis in some length in this lecture. That's all this lecture is going. It's going to stop at that. But there's 2 components to the epidermis. There are the different layers. Oh, of course, we're going to start that early. Now, let me put this, if I angle the pen, I'm better. And we have different cells. I think there's 5 different layers, 4 different cells. I don't want you to hold me to that, so I'm not going to write the numbers down. That is the epidermis, and that's kind of this first layer. Then we have the dermis, and the dermis is this bulky area here. We will see there are some very specific parts to it. We have the papillary region and the reticular region, and there's a whole lot going on in the dermis. And then we have this lower layer here, the subcutaneous layer, the hypodermis, it is also known as, and that includes some fibers and adipose tissue. Adipose tissue, if you recall, is fat. All right, so what do we have? In the epidermis, we have these cool little epidermal ridges. That is your fingerprint, but they're not determined at that level. Epidermal ridges are actually determined by this papillary area of the dermis, and that is actually what creates your fingerprints. So if you're trying to scrub off your fingerprints, you got to go into the dermis, and it's going to be bloody. We're going to study fingerprints in lab on Friday. If you are able to make it to lab, we will do that, and you won't have to do it on Wiley. What else do we have? So we have these hairs, right? These are hairs all the way down, and a hair has different regions to it. We'll learn about that because we can. You're stuck listening to me. And a hair is in a hair follicle. The part of the hair that is sticking out is the hair shaft. If it's contained in the follicle, it's a hair root. But the hair follicle is kind of its house. And well, we'll talk about specifics because it's not on here. All right, every hair follicle, this is cool, has a little muscle attached to it. And this muscle is what is responsible for making goosebumps. It will contract. And so this muscle here that's attached to a hair follicle contracts, and it yanks the hair follicle, which makes the hair stick up, and you have that little bump in your epidermis. All right, we have, hold on, here we go. We have, these are sweat glands, and they have a pore all the way to the surface of the cell. Both of these guys here are called sweat gland. We have 2 different types, eccrine and apocrine. Eccrine is your major one for cooling the body. We're just going to leave it at that for now. Oh, hey, cooling the body is the eccrine. And then we have oil glands, and these little blobs sticking off a hair follicle are oil, and oil is sebaceous gland. Sweat glands, right, they use sebaceous and not the fancy word for, they use sebaceous for oil, fancy word, but they didn't use the fancy word for sweat, and that is sudoriferous. Sudoriferous gland is also known as a sweat gland. Okay, that's it. And what do we have left? We have all different sorts of nerve receptors. We have free nerve endings. Well, let me see which ones are showing you here. Okay, they're showing you free nerve endings here. Free nerve endings we'll study in lab can be thermoreceptors detecting warmth, cool, or they can be pain. Pain receptors are free nerve endings. We have nerve endings in fancy little blobs called corpuscles, and there are Meissner ones, there are Merkel ones, there are deep ones down here, super deep pressure corpuscles called Pacinian ones. So there's a whole lot. In addition, we obviously have blood supply. But do you guys notice this blood supply is limited to the dermis? This is where the blood supply is. And the epidermis is living. There's living cells in the epidermis, but there's no blood going to it. That's why when you get a paper cut, it doesn't bleed, but you see like slices of skin, slices of epidermis with no blood. If it's bleeding, you went through the epidermis into the dermis. All right. What do we have here? Oh, different components. Well, I'm not ready to talk about this yet, but you can see these epidermal. I'm looking at this picture because this one's kind of cool. These epidermal ridges, and there's even little sweat pores all between the ridges because your hands get sweaty. This picture here is really gross. I don't know. It looks like I just see the dead cells of the epidermis. This picture here we'll look at in lab. I see a hair in a hair follicle. I see oil glands. I see dermis, and I see epidermis. And this is talking about specifics on the epidermis that we're not ready to talk about yet. Okay. So I don't know if you remember, but 2 seconds ago, okay, I'm just peeking. I said when we talk about the epidermis, there are 2 things you need to know. You need to know the different cells. And there's 4, which I knew there was 4. And you need to know the different layers. And there's 4 to 5. I had to count them in my head. So I'm willing to commit at this point. All right, we have the main cell of the epidermis. Remember, so the epidermis is the outer layer. And it has 4 major cells. The one major cell that makes up the majority of the epidermis is the keratinocyte. Keratinocyte, I don't care how you say it. This guy makes a waxy protein. And this waxy protein is responsible for like waterproofing you. Keeping in your liquid, kind of like a sealant. Okay, so it's important because otherwise you would lose a lot of moisture to your skin. You would be dehydrated, and according to lab and the movement of water, you would die. Another cell that we have is a melanocyte, and a melanocyte makes melanin, and melanin is pigment, right? This is determining the color of your skin. I mean, it's genetics, but it's based on these melanocytes, so cell that makes melanin, site, melano, and that gives you your color. One of the 3 sources of color in your skin. You have a white blood cell hanging out in your epidermis, and he's a Langerhans cells. Your book is calling it this wacky thing, the intraepidermal macrophage. He's a white blood cell. Why is Langerhans a male? I don't know. It is a white blood cell that is phagocytic. Oh, engulfs. If you remember that from before you had a brain dump, engulfs bacteria and debris. Non-specific. I'm feeling kind of funky today, I guess. Non-specific. I know the words are all on the other ones. Eats anything. Kind of like Jenny, my dog. She'll eat pretty much anything. And then you have one type of sensory neuron called a Merkel cell, a Merkel disc. And where's my pen here? There we go. This is light touch. So these are the 4 different types of cells of the epidermis. The keratinocytes are in layers. We're going to do the layers in a minute. And they make this keratin protein, which is waterproofing, so that we do not dehydrate, right? Because if you're burned and all of these layers are damaged, that's one of your main worries and concerns is dehydration. with the melanocytes making the pigment to protect you from UV damage. We have Langerhans, our white blood cells, phagocytic. And then we have the Merkel cells, which is light touch. Okay. Now, remember when I said there's layers of the epidermis? Layers of the epidermis, there's 4 to 5. In some places, there's 4 layers, and 4 layers, where there's 4 layers, this is considered thin skin. And we can have thick skin that doesn't have hair, but has sweat glands galore, and that has 5 layers. So that's why I said the epidermis has sometimes 4 or 5 layers, depending on what you're talking about. If you're talking about the palms of the hands, the palms of the feet, the fingers, that's thick skin. If you're talking about skin on your arms, skin on your belly, skin on your neck, that's thin skin, and there's hair there. Of course, we have special other areas like your lips and your genitalia that don't have hair but are thin skin. Okay, so when we have these layers, this is from the outside. So if you're sticking me with the needle outside the body, the first layer you're going to come in contact with is the stratum corneum. And if you're sticking me in the palm of my hand, so it's thick skin, the next layer would be lucidum. Then you have the stratum granulosum, stratum spinosum, and then the very bottom layer is the stratum basal, like basement. Bottom layer in contact with dermis, that reticular layer of the dermis. Okay, so I'm sure there's a picture. Yes, there is. And it's not all pretty layers, right? It's ups and downs and ins and outs. So let's look at this here. I'm sure there's words. Oh, right. Yeah, there are words, but I like the picture. Obviously, you probably noticed that about me. I'm trying to find where I am. Here we go. I'm going to start at the bottom. Stratum basal. So this is just this bottom one layer of cell. So it's one layer. Bottom. Right, well, we already said it's bottommost. These cells are alive. Cells are alive and actively dividing. These cells are alive and active, and as they divide, they push out. You will find melanocytes injecting pigment in this layer. You will find these tactile Merkel cells. Look at this, is even showing you a little mitosis. And these are all these different layers are all keratinocytes. So as we go up the next layer, there's a wacky, wonky shaped layer, is the stratum spinosum. And these guys are making keratin. They are also alive, okay? And as the basal layer is dividing, they are getting pushed up. The stratum granulosum, these cells are dying. They're dying and, come on you. They're releasing their wax, their keratin. They're a couple layers thick. Obviously, the spinosum is like more layers thick. If I'm in thick skin, I then have this translucent stratum lucidum. And then the outermost, and so these cells are dead. And then the outermost layer, which is like 30 to 50 cell layers thick, is the stratum corneum. Oh, look, it even says they're dead. And these are also dead. This is what you slough off, and you can see when you're all dried out. I'm going to talk about that in a second. But these are my different layers, and you will need to know these, right? So you want to come up with some crazy way to remember them. And I do a little mnemonic. It's embarrassing, but thank God only like a third of you are watching these videos. And so it's always the word stratum, right? And then the first one, obviously knowing lucidum is only in thick skin. LGSB. So here's mine. And mine is so corneum, lucidum, granulosum, spinosum, basal, right? You're new to this. You're not going to remember that, but I bet you remember this. Can Laura get some booty. Those days are long gone, people. But anyway, well, it still works. I can remember at least the letter order. I know lucidum's in thick skin, and then I just plunk in the other fancier words. Those are my layers. So now let's see. I have in the basal layer the keratinocytes, the pigment-making melanocytes, the light-touch Merkel cells. And when I divide, I push cells toward the surface. Push to surface. I then have the spinosum, and they are making many layers, making keratin. Granulosum are starting to die. Lucidum are dead, and corneum are dead. So having, oh look here, this will tell you basal. So this is flipped, so this is innermost. I hate when they do that, and this is outermost. But this one, oops, will tell you dead single, one layer of the basal layer. 8 to 10 of the spinosum, 3 to 5 of the granulosum, 4 to 6 of lucidum, and then up to 50 of the stratum corneum. So when you look at these layers, let me see this. See, it's all the same picture. Which ones, what's the deal with skin cancer, right? We have 3 types of skin cancer we're going to talk about. We have melanoma. Well, I don't have melanoma. I have a basal cell carcinoma. That's the one most people get, right? Basal cell. And then I have a squamous cell carcinoma. I know there's other ones, but these are the 3 basic types. Where do these occur? Where do these occur? Well, a basal cell carcinoma starts in the stratum basal. It can only happen where cells, you need living cells in order to have cancer. The cells have to be alive. So if the cells have to be alive, it's not going to be in corneum, lucidum, or granulosum. What kind of limits it? A lot. So stratum basal is where you will get your basal cell carcinoma originating. This is the slowest growing one, most easily treated. And your stratum spinosum is where you'll have your squamous cell carcinoma. This one's a little more serious. And then maybe you've already, well, whatever, you know what I'm trying to say, figured it out. Melanoma, the most serious one, is the cancer with the melanocytes. And melanocytes are slippery little suckers, and they migrate. Very easy for this to metastasize and spread to other parts of your body. So those are your 3 basic types, and now you understand they're coming from living cells. All right, the growth, I think I've already said, is coming from the stratum basal, pushing them out, getting pushed up, and then I'm making keratin, and it's accumulating in the cells until the cells are dying, then it gets pushed off, and that waxy protein, it's a protein, waterproofs you. Okay, so, oops, button, oops, yeah, that's okay. So that's the epidermis. I'm going to stop this lecture here, and we're going to continue on in lecture 2, talking about the dermis and some other characteristics of skin. I don't know if there'll be 3 or 4. We'll see. All right, see you in a bit.